A hyperbola is a mathematical equation that consists on a symmetrical open curve formed by the intersection of a circular cone with a plane and a smaller angle with its axis at the side of the cone. In a conic section, you can get a hyperbola if you slice the cone vertically. A hyperbola has a radius that is called eccentricity. It has two vertex and two vertical asymptotes. It also has two focus, and a lot of hyperbolas are used to explain space physics, and you use a lot of hyperbolas in everyday applications.
The orbit of a spacecraft can sometimes be a hyperbola. A spacecraft can use the gravity of a planet to alter its path and propel it at high speed away from the planet and back out into space using a technique called gravitational slingshot. Some theories explain that the shape of our universe is the same as a hyperbola. This technique has been used to increase the speed of the rocket that carries a robot so it could land on a planet or comet faster. A clear example is Philae. Philae is the first robot to land on a comet. The intentions of the landing were to know what the comet is made of, but to get there, the spacecraft carrying the robot needed to pass through several planets that created hyperbolas. This increased the speed of the rocket and arrived to the comet in time.
So hyperbolas can be present in medicine, engineering, and space. But there are many daily life applications where hyperbolas can also be present, like the shadow of a lampshade or a flashlight, or in a radio, because radio system signals employ hyperbolic functions. Scientists and engineers established radio stations in positions according to the shape of a hyperbola in order to optimize the area covered by the signals from a station. In medicine, they use a rectangular hyperbola to know the force velocity data in the muscle while working. This is important in medicine because when you got a muscle injured by doing exercise, the doctor may hypothesize the exact way the muscle got injured and how to have a better treatment. The approach is based on a three-dimensional regression analysis of the variable force, velocity, and force times velocity. Several methods have been used in past for fitting a hyperbolic function to experiment force and velocity data, but after several examples from the fast sciences, they conclude that scientist Hill has the most simple fitting hyperbolic equation to know force velocity data in the muscle using conventional statistical techniques.
If the hyperbola is horizontal, the domain is always infinite, and to find the range, you need to look for the vertices and take away the part in which the hyperbola is not touching any point. If the hyperbola is vertical, it is opposite. The range is always infinite, and for the domain, you do the same as the range in a horizontal hyperbola.
Our conclusion on this topic is that the use of hyperbolas is present in our daily lives and we don't always notice it. I personally believe that hyperbolas should be used in the engineering sector because it is in engineering that they are used the most. Another important use for hyperbolas could be in telescopes. With the increasing information in new planets and stars, better quality telescopes would be of huge help for research and further discovery.
I think hyperbola should be used mostly in architecture in order to make more buildings without having to use a traditional structure, because the world is modernizing and it will be nice if the architecture changes too in a good way. For example, the Sydney Opera House, where we can see clearly the hyperbolas formed.
In conclusion, hyperbolas can be used on many areas in life, pretty much anywhere as long as it has something to do with a symmetrical open curve, and that's a hyperbola. For example, the shadow of a lampshade or a flashlight, but we usually don't even notice they can be hyperbola examples. Hyperbolas are related on many things, like space, engineering, etc., but not all as in medicine. In fact, after an hour of research, I could find out one thing that medicine is related, and it was muscle force velocity data. Scientist Hill created a way to find out the force velocity data of a muscle in a hyperbolic function. I believe that doctors should try to find out new ways of using more hyperbolic functions when analyzing the patient. By doing this, the doctors could have a better hypothesis of the problem.